Hello everyone, welcome back to my YouTube channel. My name is Harshini.P.V. Currently pursuing my BE in Sri Venkateshwara College of Engineering. My USN is 1B23CA021. Third SEM, Section DEVO, Branch CSCAI, Subject Operating System, Subject Code BCS 303, Topic about Operating System. Contents which we are going to cover today in this video are operating system definition, advantages of operating system, disadvantages of operating system, computer system structure, computer system architecture. Firstly, let us see about the operating system. What is an operating system? An operating system is a system software that acts as an intermediary between a user of a computer and the computer hardware. It is software that manages the computer hardware and allows the user to execute the programs in a convenient and efficient manner. Let us look about the advantages and disadvantages of operating system. Firstly, let us see advantages of operating system. Operating system provides a GUI interface for user in the form of menu, icons and buttons. Operating system also allows us to share the resource with other user. It helps user to understand the function of the computer. It is very easy to use. And some of the disadvantages are if the operating system is corrupted, then it will affect entire system and the computer system will not work. Only same task run at a time. Now let us see about the computer system structure. Computer system mainly consists of four components: hardware, operating system, application programs, word processor, users. Hardware provides basic computing resources like CPU, memory, input or output devices. Operating system, it controls and coordinates use of hardware among various applications and users. Application programs defines the way in which the system resources are used to solve the computing problems of the users. Word processors, compilers, web browsers, database systems, video games. Users like people, machines, and other computers. Now, let us see about the computer system architecture. Types of computer systems based on the number of general purpose processors. Single processor systems, multiprocessor systems, clustered systems. Computer system architecture. It is categorized roughly according to the number of general purpose processors used. Firstly, let us see about single processor systems. On a single processor system, there is one main CPU capable of executing instructions from user processes. It contains special purpose processors in the form of device specific processors for devices such as disk, keyboard, and graphics controllers. For example, a disk controller processor implements its own disk queue and scheduling algorithm, thus reducing the task of main CPU. Special processors in the keyboard converts the keystrokes into codes to be sent to the CPU. The use of special purpose microprocessors is common and does not turn a single processor system into a multiprocessor. If there is only one general purpose CPU, then the system is a single processor system. Now let us see about the multiprocessor systems. It is also called parallel systems or tightly coupled systems. Systems that have two or more processors in close communication sharing the computer bus, the clock, memory, and the peripheral devices are the multiprocessor systems. Multiprocessor systems have three main advantages: increased throughput, amount of work completed in a time, In multiprocessor system, as there are multiple processors, execution of different programs takes place simultaneously. Even if the number of processors is increased, the performance cannot be simultaneously increased. The speed up ratio with n processors is not n, rather it is less than n. Thus, the speed of the system is not as expected. Economy of scale. Multiprocessor systems can cost less than equivalent number of many single processor systems. As the multiprocessor systems share peripherals, mass storage and power supplies, the cost of implementing this system is economical. If several processors are working on the same data, the data can also be shared among them. Increased reliability. Probability that a component will perform its function for a specified period of time. In multiprocessor systems, functions are shared among several processors. If one processor fails, the system is not altered. It only slows down. The job of the failed processor is taken up by the other processors. Two techniques to maintain increased reliability: graceful declaration and fault tolerant. Graceful declaration. As there are multiple processors, when one processor fails, other process will take and its work and the system goes down slowly. Fault tolerant. When one processor fails, its operation are stopped. The system failure is then detected, diagnosed and corrected. There are two types of multiprocessor systems: asymmetric multiprocessing, symmetric multiprocessing. Asymmetric multiprocessing, called master or slave architecture. Here, each processor is assigned a specific task by the master processor. A master processor controls the other processor in the system. It schedules and allocates work to the slave processors. Symmetric multiprocessing. All the processors are considered as peers. There is no master slave relationship. All the processors have its own registers and CPU. Only memory is shared. Clustered system. Like multiprocessor systems, but multiple systems working together. Usually sharing storage via a storage area network provides a high availability service, that is service will continue even if one or more system fails. Asymmetric clustering has one machine in hot standby mode. Symmetric clustering has multiple nodes running applications monitoring each other. Some clusters are for high performance computing. Applications must be written to use parallelization. Some have distributed lock manager to avoid conflicting operations.